making another video. Probably shouldn't, but yeah, too bad. Let me turn the light on here. See if that light. Oh, it doesn't work. Change the batteries. Okay. Never mind that plan. I guess I couldn't turn it off the last time. I could always turn this light on, I suppose. Anyway, sorry about that. That's just totally, I had to have better planning than that. But anyway, it's probably too much. So anyway, I saw this documentary, Is Everything We Know About the Universe Wrong? And they're basically just, I mean, they're going through the dark energy, dark matter thing, the Big Bang thing, and you're just like, man, they call this the standard model. I guess they have a standard model for the universe. I don't know. It all sounds kind of wacky. Well, anyway, so there was a few people, though. There's a couple of critics there, just saying, maybe we got it all wrong, so that was the good part. I figure I might try to contact those professors and such. But anyway, I just thought I'd talk about some of this stuff because it really is irritating. This is where they just create math, to fit the outcomes. So I thought I'd just go through some of this crap that I find just really irritating. So the first argument made is that somehow, you can't have this explosion thing, the singularity explosion, and somehow it doesn't work, coming out even. And you're just saying, well, yeah, that's because you're starting with a circumstance that can't exist, which is a pinpoint that has all the mass of the universe in it, which, what kind of, it's a form that matter is never in. So why are you assuming matter is going to be in a form you have no evidence that could be in? We know that suns blow up, and they blow up for a reason. It's because they break down as a machine. The atomic structure fails probably because of some kind of circumstance like that. The matter's in a configuration that's not acceptable. And you could argue that the Big Bang was the product of something like that, but it wouldn't be anything like a singularity. It would be, so I guess they want the universe to come from nothing. So they're really not even thinking of an oscillating universe or anything else. They're just saying, let's try to make nothing create something. And now we'll figure out mathematically how you do that. So I guess they have a problem in releasing these photons, and that's all you're really doing is just releasing, or gravitons, whatever you want to call them, releasing these little arrows to go on their way in this explosion. And that's all that's happening. It's all that's happening in a nuclear bomb. I mean, you're just releasing the energy in the atoms, a portion of it. The neutron goes in, breaks up all these nucleuses. Neutrons, for every nucleus it hits, 2 neutrons go flying out, blah, 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 blah. It just multiplies the neutrons. That's the chain reaction. And the matter, it just disintegrates the matter. It decays it rapidly. It causes rapid decay. And that's kind of what all this heat thing is a kind of decay. When something's hot, it's hot because it's decaying. The photons are leaving. And they're photons because that's what electrons spew, and that's what all these other atomic elements spew, are usually things at a frequency. And we measure it as infrared radiation primarily. But they're just photons. There's no... All you can have is a lot of photons, but you can't have anything super hot in any other sense than you have a lot of photons, and the matter becomes very unstable because there's a lot of things banging on it and breaking bits off of it. And that's all heat is. I mean, a photon is as hot as the universe gets, in a sense. It's as hot as it gets. All you can do is have more little heats, more. You can't have higher, in a sense. So it's a volume issue. So anyway, and so in theory, you could have a Big Bang that would certainly be a bubble. There's no... They say it wouldn't be even. Oh, it's in a place where nothing, surrounded by nothing. Presumably, it got into that condition somehow. But I mean, there's no reason to not think it wouldn't spherically explode, and that it would do so evenly in all directions. It's not a stick of dynamite with a fuse in one end. It's not like one end's going to explode sooner than the other ends. It's an instantaneous release of the energy And I would argue that it had to be in some way contained, so there had to be something more than just photons, because if it was just photons compressed, um, they'd all have a trajectory and they would never hit each other. They'd all go that way, whatever that way is, you know. And so the bigger you make this thing, then you can have some complexity, and that you could have photons that go into the explosion when they get released, so to speak. But in some way, you have to first contain all the energy in the all the matter and energy in the universe. So it has to be contained in some kind of thing, which is just an unbelievable notion to start with. But anyway, I mean, it's believable in the sense that they have some evidence for it. But anyway, that's the explosion. So I'm just saying nuclear bombs are really symmetrical. There's no evidence of this lack of symmetry that we could expect. I mean, we've seen nuclear bombs from above. I mean, it's very symmetrical. There's nothing unsymmetrical about the mushroom cloud or all that stuff. I mean, I guess that's the rebound, actually, but it all looks very symmetrical. So what's the problem? If nuclear bombs can be symmetrical, why can't the Big Bang? So right there, I'm like, your premise is it can't happen. And I would argue that maybe you're starting with a wrong premise. Alright, so anyway, anyway, to fix that problem, they had to do this inflation thing. So we had a Big Bang that was really a little fizzle, and then you had this boing, and the whole universe just flew out into a huge expansion. And that way the mathematics, it works out that now we can make it even somehow. Because somehow they allowed it time to regularize in some way, for stuff to go sideways and mix together like a bunch of fluid dynamics or something. And I'm still going to argue, these are photons, for fuck's sake. They like to run in straight lines. They don't like to do flowy stuff. So all this doesn't make much sense. But anyway, so let's just say you had this, whatever, the explosion, as I'm arguing, and we're just part of the pressure wave. The compression, because it did have a shell, and we're part of the stuff that was on the wrong side of the shell, so to speak. So we couldn't just go that way. We keep getting hit by the radiation of the shell bouncing back, and that's the background radiation. And so we're just caught in this thick area where there's gravity, and out there isn't. And stuff just poof, that's it, instantaneously just flies off because it doesn't interact with anything anymore. It's gravity that's creating time, in a sense, because it's creating junk that the photons have to junk their way through. But anyway, I don't need to get into that part of it. So let's just get to the stuff where they create these. Okay, so they create this fake inflation stuff, and a lot of this stuff is all based on redshift. So some of this stuff, well, they have now dark flow and dark energy. So the dark energy is the thing pushing everything apart. That's somehow creating the new expansion. And so it's just made up, because they're saying it's expanding. We have to put some anti-gravity force into space and pretend everything's flying away from each other, even though we don't see any evidence of it in our own solar system or in anything around us. We're supposed to believe it's all over the place and it's doing this pushing everything apart thing. And it's all based on redshift. So they never talk, like in these documentaries, they never say anything like that. They never point out that the evidence is just really, they saw something redshifted and they're saying, gee, it's moving away from us really fast. And as I've pointed out, stuff that's going at a velocity that's moving horizontally to us, the light coming from that, a star moving horizontally to us, the light coming off of it will look redshifted, even though it's not going away from us. It'll look redshifted because, even if you bought the Einstein thing, but more specifically, velocity slows down metabolism, which means the sun actually creates redshifted light. It's redshifted coming from the sun because the sun's metabolism slows down as the sun acquires velocity. And you're like, how can they not know this or surmise this? So anyway, that's what it's all based on. And so their calculations of redshift could be really, really wrong. I would almost argue that for stuff that's actually moving towards us and away from us, the redshift is doubled, in the sense that the stuff moving away from us not only has the slower metabolism redshift, but it also has the redshift of the fact that it's moving away. So it's double redshifted. So its velocity isn't what it might appear to be, because we're not accounting for the fact that the redshift is twice as high as what the actual velocity would be, because it has a redshift from both components. So its actual velocity is only half of what they're estimating it to be. But it's all based on that premise, right? Like if they got redshift wrong, they've just assumed redshift, they've correctly understood redshift, and they're correctly associating redshift with certain kinds of movement. And if they have any of that wrong, then all of it's wrong. Because it's the only thing they're using as evidence. It's all they have as evidence. That's it. Alright, so now the dark matter thing. So this comes up because of a lot of reasons. The lensing problem, the gravitational lensing doesn't make any sense because it's in places it can't be, because there isn't enough gravity. My argument is that's because it's not really gravitational lensing. But anyway, so they have to contrive and add the dark matter to the galaxies, right? And they're saying the dark matter going through us right now, that it's in our own solar system right now. And yet there's absolutely no evidence having to account for it. Somehow it hasn't affected any of the planets or the moon or any of the orbits of anything in this solar system, and yet they're saying it's here. So it does affect gravity when it's in the galaxies, but it doesn't affect gravity when it's in solar systems. That doesn't sound exactly right. That sounds ludicrous, is what that is. It sounds like absolute nonsense. It does, right? Yes, it does. So, but anyway, another problem they found is that the galaxies are spinning too fast, right? The outside of the galaxies are moving too fast. The stuff on the outside is moving too fast. It should be going slower because it's on the outside. See, but this is the thing that they don't fundamentally understand what gravity is, so that's why they get it wrong. They think gravity's come from the center thing and all this kind of crap, and the feature about galaxies, when you look at them, you say, well, what's the difference between a galaxy and a solar system? Well, first, there's a ton of stuff in a galaxy orbiting, and clearly there's stuff on the opposite side. It's like us having an Earth on the other side of the sun. Galaxies are usually quite symmetrical, and there's mass on one side and there's mass on the other side, and that's a big difference, right? Because gravity has to move the speed of light. No one's recognizing this one either. Gravity's not an instantaneous force. It's moving exactly like it should, just like a photon, right? Gravity is photons, right? Photons are gravity. And the difference is gravity doesn't have a frequency, and gravity isn't polarized. So it goes into a magnet, of course. And light is. That's the difference. Same exact stuff, polarization and frequency. That's how we detect everything on the electromagnetic spectrum, is because of its frequency. The stuff we can't see, the light we can't see it because of its frequency, not because it's different, not because it's fundamentally different. No, just because our electrons can't recognize tighter or bigger frequencies. I mean, it's, wow, so obvious. So obviously we don't see gravity. But gravity's doing the same thing photons do in a lot of respects, except gravity doesn't interact with electrons at all. I mean, interact in the create a polarization and create frequency. Gravity doesn't do that part. It does the velocity part, it does the acceleration part. That's where you're basically getting your acceleration from, is you're absorbing some portion of the gravity from the field and possessing it and moving with it. Alright, so anyway, but I've been through that. So I wanted to get to the spiral thing. So, I mean, there's, galaxies have this very bizarre shape, right? I mean, these loopy arms, the spokes to the wheel kind of thing. And that should be a giveaway that the dynamics of their gravity is a little bit different. Maybe there's something that tells you. And the thing is because they're so big, right? So it takes a really long time, a million years to go from one end of the galaxy to the other end of the galaxy, a million light years. Maybe more than that for some, I don't know. But I mean, they're really big. It takes a long time. And so what's really happening is that the gravity, because of that long time it takes for the effect of the gravity for one thing to actually be felt by the thing on the other side, is that these spirals are really what's happening is that the outside spiral on one side is being affected by the gravity of the inside spiral on the opposite side. So the stuff really close to the center of the galaxy is creating the gravity for this outside spoke, and vice versa, crisscrossing the sides. And so that's the thing that's fooling them. It's because of the time delay. So the actual thing that was creating the gravity, the actual thing that had the acceleration that moved in towards the center of the galaxy, absorbing gravity, therefore creating a shadow effect that the other side's going to feel, and they're going to feel it by moving in to that lower pressure. What feels it is the stuff much later, the stuff on the outside of the spoke, the stuff that shows up to the right location a lot later. And that's the explanation. But you have to understand gravity to understand how this works. Some of it is, I don't know how to, but see, that's why gravity diminishes so over distance. Is fundamentally not because gravity's focused. Unlike other light, that just shoots out of a light bulb in all directions. Gravity is very focused. The acceleration, when the Earth moves into the sun, it moves into the sun in a very specific plane. And it's that very specific plane is where the shadow is for the gravity it absorbed. It's casting a shadow, but it's casting a very narrow shadow. It's not a everywhere shadow. It's everywhere on that plane, so to speak. I mean, it's everything forward is getting some element of the shadowing effect, because some elements of the acceleration will be forward, straight at the, like some, you could see the Earth sitting out here, and you're the sun. The Earth is absorbing acceleration in all the direction, certainly right towards the sun, in all the directions that are on that plane of, the two sides of that dimension, the width dimension, whatever you want to call that. And so everything on the one side of that dimension will add up to the gravity, but clearly most of the gravity is directed in the direction of the sun, in the sense that that's where the strongest amount of acceleration has been absorbed. Yeah. Oh, yeah, I knew that was going to happen. I do. I mean, I thought this would work, but yeah, it's just this. It gets too warm, I guess. It's not even that warm, but it just gets warm enough that the glue melts. So I'm going to have to put it on with something better. Anyway. So yeah, it's a really important thing. But I think, just the fact that I don't think they really understand the mechanism. Obviously, they don't understand it. That acceleration is when you're absorbing gravity. That's when you're creating the shadow. When you don't accelerate towards something, gee, that's really inconvenient. Stay on there. Well, anyway, I'll cut this short. Let's see if you cut you a break, because I think I covered it. Oh, yeah, they have dark flow now too. So apparently a bunch of galaxies are flying out of the universe, or heading for another universe, or doing some kind of bullshit. And again, it's all based on combining telemetries on their background radiation with I don't know how they exactly figure out how much a bunch of galaxies are moving, but whatever. It's all quite thin science. And so, yeah, I can't even say much on that subject. But I don't think there's other universes that are pulling galaxies out of our universe or anything. It sounds contrived. So anyway, I think I covered all it. Dark energy, dark matter, vast galaxy. So that's basically all that was in this documentary. But really, it just starts with these premises, and then they have to validate the premises, and so they just engineer them. They put a new square thing in the math with a p on it or something, or cubed, or triangle, some other kind of crap, a theta, and pretend that's reality because we drew it in an equation, and now the equation says so. I don't think so. I don't think that's nearly good enough. But anyway, that's all. I mean, there was some other little simple observation I made that was, just that, every day some little thing pops into my head and I say, oh, that's, but yeah, I don't know where I wrote it down. But anyway, so yeah, let's see what I can do. See if I can get, we can get one of these decent professor types to take a couple $1,000 to, read my paper, watch a video, and then maybe have an hour Skype. I'll be satisfied. Yeah. So anyway, see what I can get. For what price? They probably just can't afford to hurt their reputation. But if I'll basically just I don't mind letting them. Be a consultant or something. They can call themselves something else. They can be in on it. Yeah, just I get there with a shorter cut than fucking around for years trying to get the empty space, the dark matter to listen. So anyway, until next time. Piro left some stupid comment. He always does something irrelevant. I mean, yeah, okay, it was part of the video, was the subject of the stupid software that these publishing houses have. But and he suggests open office, like, I don't know what open office is. Jesus. Duh. It's not the point. It really wasn't the point. It's just these are supposed to be scientists. Scientists should have some kick-ass software. That's all I'm saying. Physicists they should have enough computer. What do you call them? Computer something or others. They should have enough of that kind of stuff. That kind of. I mean, they should be on that technology crap. They shouldn't be fucking around with half-ass. Document software. I mean, they should have something that kicks ass. But anyway, just a critique. And so instead of dealing with the critique, he just, some half-ass solution. It's not really a solution. Well, okay, so I will glue this for the next video, I promise. Anyway, till next time. And such. I don't know, I think it probably focuses better when it's close, but then that sort of defeats the whole purpose of the fishing eye, right? Probably does. Well, anyway, we'll see. Till next time.